a transformation is. Hold on, let me make sure I'm recording this because there's so many people. If I hit go. Yes, I am. Okay. So a transformation. A transformation is when we are performing a specific rule. So let's fill this in. Performing a specific rule. So they're going to tell you what to do on a figure that's going to change its size, its shape, or its location. So it may move somewhere else on the graph. Sometimes it'll do all three, sometimes it'll only do one thing. But a transformation is going to be a rule that will change a figure's size, shape, or location. There's two main types of transformations that we need to be aware of. The first one is a rigid. Any thoughts on what rigid might mean? Patty?
Like the shape is the same.
Good. It's going to stay the same, like a statue. It's going to stay solid. It's not going to change its shape. So it will not change the size or the shape. It's only going to move it somewhere else. So when a transformation is rigid, it's going to keep the size and shape the same. It's just going to move it somewhere else, much like this example. So then non-rigid it can change the size or shape of your figure. If it's non-rigid, it might change one part, its size, or it might do both, change the size and shape, if it's not rigid. We only have one transformation this year that's non-rigid. The rest will be rigid. It will just move its location. It won't change its shape or size. Alrighty. Now let's talk about our transformations. There's obviously going to be two versions. Right, you're going to have the original before you've done the transformation on it, and then the transform figure. And they have specific names. The pre-image, what does pre mean? Before. So it's the figure before a transformation is made. It's basically the original figure. I spelled that wrong. And you would label the original figure with just a capital letter. So maybe look up here, mine might be a little bit more clear. Is the purple or the blue the original with just a capital letter on it? The purple. So you just arrow over to purple. That's our pre-image. Then when you've done a transformation on something, we call it the image. That's the new image. It'll be image or new image. So that's the figure after the transformation's done. You'll label the exact same points with the same letter, but what do you notice that's different on it? It has a little thing, has a little apostrophe. Yeah, and we call that a prime. The little apostrophe is the prime. So we call that A prime or B prime, C prime. After you've done a transformation, so that anybody looking at it knows that's the transformation, you include a little prime. So A will still be A, but you give it the prime to show this is the one that's been transformed somehow. Okay, so the pre-image is before, image is after, and you include the prime on its letter. Now, let's talk about our first transformation. It's going to be a translation. Just by looking at the graph, what kind of movement are we making, do you think?
It's just like moving places.
Yeah, it's just moving places. It's like you stick a piece of tape to your hand and you just slide it somewhere else and drop it off. Did it flip over at all or turn around? No. So a translation, it's just going to move every single point. It'll move every point of a figure the same direction. Oh, I should say distance first because I've got same over here. Sorry. The same distance in the same direction. So every point is going to move the exact same distance and in the same direction. So C went to here, B went to here, and A went to here. They move the same distance, same direction. So if we do a translation, if we stick that piece of tape to your hand and just slide that triangle somewhere else and drop it off, is it going to be rigid or non-rigid? Yeah, it's going to keep its shape and size. So this one is a rigid movement. Okay, it's a rigid transformation. Now let's talk a little bit more about the specifics of a translation. A translation is going to actually map, or we can call it a slide. It's going to map or slide each point of the figure along what we call a vector. We'll talk a little bit more specific about that in a second. So your translation is going to map or slide each point of the figure along a vector according to a specific rule. And this is one version of the transfer or translation rule that you're going to see. Every translation is going to be unique because it will have its own special rule. So the way you read this kind, it says every x, y goes to, we write that on there, that little arrow says it's going to go to, so every x point of your every x coordinate and your y coordinate of your point will go to x plus 4 and y minus 9. So these are giving you the direction and how far to go to take each point. So x, do you think that's a right-left motion or an up-down motion? Right-left. So we just do a little right-left by the x. The x is going to send you right-left, depending on plus or minus. So the y, which direction? Up-down. Okay, so if this particular one says x plus 4, do you think that's right or left? Good. Well, you show that's going to go to the right 4, y minus 9, up or down? Down 9. So let's just take a look at C. It's saying C went to the right 4 and down 9 to get to C prime. So it went to the right 4 and down 9. And it followed what we call a vector. Every single point goes to the right 4 and down 9, right 4 and down 9 for this particular translation. Now it followed a vector path, which is actually the straight line taking it from its original point to its prime point. So let's talk about a vector really quickly. Let me just remind you what a vector is with this. So vector, get on there. Push back. Yes, go back. There we go. Thank you. Okay, so a vector, it's a mathematical term of an arrow representing two things. What two things did he say it represented? Direction and magnitude. So our vector, it's actually an arrow showing direction, obviously, and then magnitude is actually its length, its distance. So a vector is an actual quantity that has both, I want to say the right one first, direction and magnitude, which is its size, its length. It's an arrow. Okay, so it's a quantity that has both direction and magnitude, It's represented in the coordinate plane by an arrow drawn from one point to another. So that's what a translation will follow. It'll follow a vector from the original point to its prime point, and each one will follow the same vector. It'll follow the same direction and the same magnitude or length or size. And our coordinate rule that we just saw tells us how to make that happen. Okay, so on a vector, it's got two pieces basically. It's going to have a horizontal motion that we saw, an X right or left motion, and an up or down motion. The P in this example, it's the original point, the beginning point, and Q is the what we call terminal point, or the ending point of our vector. And so the component form, we call this the component form of a vector, is going to combine that horizontal, which is our x's, and vertical component, which is our y, up or down component, to create the vector notation. So the component form of vector PQ, this is how we note it with these pointy brackets. It's saying x is 5 and y is 3. X is 5, is it going right or left? To the right. If y is 3, is it going up or down? Up. So we can see both forms. We're going to see the coordinate notation like we saw very first, or the vector notation telling us to go right 5, up 3 on this one. So that's vector notation. Now this is how you actually do a translation. It's actually pretty easy, pretty cool. So we're basically going to grab that triangle, slide it somewhere else, and drop it according to our rule. So our first job is to move each point according to the rule. So we got to know what the rule is telling us. X minus 5. Which way does that want me to go? Good. So arrow or show that on your notes. Left 5. And y minus 2. Where are we going?
Down.
Down 2. So you start on any point you want to. Let's just start with A and go 1, 2, 3, 4, 5 left. Down 2, plot it again, call it A, but with a prime. You have to put that prime on there. That is detrimental for a transformation to show that's the one you've moved. Do the same with each of them. Left 1, 2, 3, 4, 5, down 2, plot it, call it the same variable with a prime. C goes left 1, 2, 3, 4, 5, down 2, plot it, C prime, and then connect them nice and neat. If you want to borrow a ruler today, you can. You want to make it nice and neat so it looks like the original. Like you just grabbed it, slid it, dropped it. And there it is. Labeling each point with a prime, connect them nice and neat. So nothing too tricky. Here's our next rule, x plus 3, y plus 5. X plus 3, which way are we going? Right 3, and y plus 5, which way? Up 5. So grab a point, take it 1, 2, 3, up 1, 2, 3, 4, 5, plot it, give it a prime. F 1, 2, 3, 4, 5, up 1, 2, 3. I didn't go over it. F prime. 1, 2, 3, 4, 5, up 1, 2, 3. D prime. And there it is. That looks wrong. There's what is wrong. 1, 2, 3, up 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. I go up. Hold on. 1, 2, 3, up 1, 2, 3, 4, 5. There we go.
I had to sit in a room.
Up prime, 1, 2, 3, 1, 2. And there is our new image. The new image slid right 3, up 5, following a vector to get there. Slide it. I know that'd be cool. Huh? Okay, we can do the exact same thing even if our rule is given to us in vector formation. The first number you just put right here is going to tell you your x direction. The second one's going to tell you your y direction. If you see the pointy brackets, that's vector notation, but it's basically telling you to do the same thing. If my x is 4, am I going right or left? right 4. How about if y is negative 3, which way am I going? Down 3. So again, take each figure right 4, point I should say, down 3, plot it, and give it a prime. Right 4, and down 3, give it a prime. 1, 2, 3, 4, 1, 2, 3. And then you've got your triangle translated. So no matter how they give you the notation, it's going to tell you to do the same thing. The x, this one, negative 5, which way? Left 5, thank you. And negative 6, you guys up or down? Down, thank you. So left 1, 2, 3, 4, 5, down 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. That's down. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And there's actually little shortcuts you can take. 1, 2, 3, 4, 5. If you want to, if you figure out a shortcut, you can do that as long as it's getting in the right spot. Shortcuts are just how F is far away from B. Once I get F, I know it's down 2 over 1 to get to B. Do stuff like that. That's really fun. Any questions on how to make a translation happen on a graph? Okay, then you are going to be given the ordered pairs of the vertices without the picture and asked to still translate them and just note where they would land. Your coordinate rule is telling you what to do to every x and what to do to every y. It's saying every xy is going to go to x plus 5 and y plus 1. So if u starts at negative 4, negative 2, do this with me, u prime, it's going to follow this translation rule to get there. It says take your x and add 5. So what's negative 4 plus 5?
1.
1, and then take your y and add 1. Negative 2 plus 1? Negative 1. And then we do the same with b. What's negative 4 plus 5? 1. 3 plus 1? 4. And then w prime, 0 plus 5? And 1 plus 1? 2. So that's where this triangle would land, even though we don't have an image. Are we okay doing that kind? Okay. So if this was my coordinate rule, take every xy and go to x minus 1, y plus 3, w prime. Where's it going to land? 0, 2. Yes, everybody feel good about that? It says take your x and subtract 1, take your y and add 2. So if we do that, what are we going to get for x prime? 1 and 5. Y prime, what's it going to be? 4 and 0. Everybody feel good about doing that without a picture? Any questions I can clear up on that? Okay, so we can do it with or without a picture as long as we know the rule and the endpoints. Now we're also going to have to go backwards. They're going to give you the picture of the translation done, and you're going to have to come up with a rule. So this is how we do it. So make sure you fill this in so you know. You're going to choose one original, choose one original point. So just a plain old A, a B, a C, whatever it is, no prime, I'm not original. So for the X part of the rule, you need to count how far right or left you go to get to the matching point, the new point, the A prime. That will become the X plus or minus of your coordinate rule. That'll be every x, y goes to, and then x, right or left, will count. And then we do this a similar thing for the y part. For the y part of your rule, you count how far up or down you need to go to get to the new point A prime, and that becomes the y part of your rule. Y plus or minus, whatever. So pretty easy. The key is though you have to start on the original point and count how far it takes you to get to the new point. So let's try it. Here we've got two images. A translation was done. Which one's the original? The black or the blue? Black. How do you know? No primes. Okay, so let's just pick a point. Let's just all pick B. Will you box out B? And then let's box out its matching B prime. and we're gonna write the coordinate rule. You do have to write the whole thing, so you'll always start every x, y is gonna go to, that's how you start a coordinate rule, and then we're gonna get the distance and direction. So v, to get to v prime, is it gonna go right or left? Left, so is it gonna be x plus or minus? Minus, and then you count. 1, 2, 3, 4, 5. We gotta go left 5. Are we gonna go up or down to get to v prime? Down, so plus or minus. Down, how far? Down 3, and you've got the coordinate rule written. Okay, nothing too tricky. Okay, this one, original, is it black or blue? The black one, again, pick any point. Let's just maybe go from G to G prime. You start your coordinate rule every time by saying every x, y will go to. You gotta have that part of it. It's a big part of the rule. So if I'm going from G to G prime, am I going right or left? So x plus or minus? Right? We gotta go to the right, yes? Gotta go to the right, how far? 4, are we going up or down? So plus or minus? Plus how many? 2. Any questions I can clear up on writing the coordinate rule? Okay. Now we can also write it in vector formation. It's the same idea, it just uses those pointy brackets, and we don't have to include x or y, we're just going to include the amount we moved with its positive or negative direction. So original, look at these two triangles, black or blue is the original. Black. So maybe we'll just go from H to H prime. H to H prime. So let's include the word translation. It's a translation, and then we're going to do our vector formation. So we got to have an x movement and a y movement. If I'm going from H to H prime, am I going right or left?
Right.
So is it going to be a positive or a negative x? Positive, and how far did it go? Just 1. The y, did it go up or down? Good, so what would it be? 0. Yeah, it didn't move any. Good job. Okay, this last one, black or blue, is original. Black. Are we going right or left? Left, how far? 4, so left would be a negative 4. Are we going up or down? Up how many? So positive or negative 1? The translation, negative 1, 1, following the vector, negative 1, 1. Yes, sir. I think, does it say? Let me see if it says. I think